Thank you very much, and thanks everyone for coming. That's amazing to see the full house here in Search devroom, and excited to be here at FOSDEM 2026. And on this session, we'll talk about OpenSearch and the search innovations with OpenSearch v3. I'm Dotan Horvitz. I'm OpenSearch ambassador under the Linux Foundation. I'm also a CNCF ambassador, and on my day job, I'm a senior open source advocate at AWS. And I'll be co-speaking with Ashwat, senior search engine architect for OpenSearch at AWS. So for those who don't know OpenSearch, it's essentially a platform for AI-powered search, observability, and analytics. On the search side, it provides the full suite from lexical search to dense vector search, neural sparse search. We had an interesting talk now, hybrid search, multimodal search, agentic search, so the full end-to-end search capabilities. It's Apache 2.0 open source license. It's a top-level project under the Linux Foundation. It started back in 2021 as a fork of Elasticsearch and Kibana after these projects were relicensed from Apache to a non-open source licensing scheme. So the community wanted to keep them open. AWS stepped up and initiated the fork. And then fast forward to 2024, AWS transferred the project to the Linux Foundation. So it's owned by the Linux Foundation or any vendor. And there's the OpenSearch Software Foundation under the LF to foster open governance and open collaboration. And I'm really happy to say that many companies have already joined the foundation. You see some examples here, Uber, SAP, NetApp, IBM, and others, and are taking part in stewarding the future of this project. There's a massive code base, 140 repos under the GitHub org, 1.6 billion downloads to date. It's a super active project, more than 3,000 active contributors from more than 400 different organizations. It's actually, I think, I checked the LFX leaderboard. It's, I think, the 12th top active project under the LF amongst the nearly 1,000 projects, so pretty impressive. And the biggest news in the past year has been that after 3 years of 2.x, we finally reached version 3, the next major release. And this major release has foundational changes. Also, Apache Lucene moving to version 10. We have architectural changes, such as the reader-writer separation to separate between the search and the indexing workloads, streaming architecture and pool-based ingestion, native MCP support, many new commands on the PPL, the piped processing language, the query language we have as part of the project, and support out of the box for Apache Calcite as the engine, and much, much more. So on this session, we'd like to share with you some of the highlights of v3, and I would like to hand it over to Aswat to start showing us the stuff. Go ahead, Aswat.
Thank you, Dotan. Okay. Okay. I'll start. Thank you. The sparse encoders, the neural sparse search within OpenSearch. I like to call this as a budget-friendly semantic search. And if you have used the dense vectors, you will probably agree with me. The neural sparse model that is there in Hugging Face, pre-trained by OpenSearch, is one of the most popular, most downloaded sparse model. But the catch with the neural sparse search has always been the scalability. Beyond 10 million documents, the latency is... Oh, okay. Yeah, so beyond 10 million documents, the latency is quite high to an extent where I start recommending dense vectors. But at that point, you are no longer in the budget-friendly semantic search. So with this seismic algorithm implementation, we are able to push past the 10 million ceiling. Yeah, we are able to go to billion with a B. Yeah, and this is by being able to do approximate sparse retrieval. Yeah, so with a new data structure, the forward index that actually has the doc ID to the full sparse vector mapping. And then we have the inverted index, which probably most of you understand, but with some slight changes, where the posting list goes through a pruning process. It only retains the top weighted doc IDs. So for example, let's say the term dog exists in doc 1, doc 2, doc 5. And each document, the term dog exists with different weights. Yeah? So pruning essentially removes those docs that have lower weights. And then what we do is we group similar documents, forming a cluster. And for every cluster, a summary vector is created. So which is what you see in block 1, block 2. So it's basically the cluster with the summary. And now that the index is created, during search time, the query vector queries against the summary vector. If the score is too low, the cluster is simply skipped. If the score is decent enough, then the cluster is examined. And for the full final score, we go to the forward index, fetch the full sparse vector to do the final score calculation. Yeah. So this is how it works. Just to summarize, so ingestion, then a pruning process happens, and then similar documents are grouped together, forming a cluster, and every cluster gets a summary. Block 1, block 2, yeah. Search happens. When the search happens, we query the summary vector. If the score is too low, the cluster is skipped. If the score is big enough, large enough, then we examine the cluster. And the cluster is examined, the full vector is gotten from the forward index, and the final scoring is done. So this is how we are able to do approximate sparse retrieval. And this is how we are also able to scale beyond 10 million ceiling that we had in the past. Yeah. So give it a shot, give it a try. Let us know how it goes. You know the drill. Yeah. So V3 GTE is the SOTA inference-free pre-trained model that I was talking about, the most popular, most downloaded Hugging Face model. Yeah. And like I said, right, so the benchmark that we did over 1.3 billion doc set, the benchmark that we did, look at the box here, the latency with the BM25 as baseline, we were able to get 4 times faster than BM25 and about 11 times faster than the traditional neural sparse search. Yeah. And the line above tells you the recall, which is a slight drop in recall. As a such architect, such practitioner, for me, a slight drop in recall with such a benchmark latency that I get is a tremendous trade-off for me. I'm not sure about you. Yeah. So yeah, please try, give it a shot. Yeah. So I will move on to a new topic, system-generated search pipeline. But in order for me to explain this one, you need to know that search pipelines exist with OpenSearch. And such pipelines are very similar to the ingest pipelines, bunch of processes for data transformation that you put together, but on the search side, right? The only difference is the processes are of different types. It could be request or response processor or face processor. To give you some tangible examples, the normalization processor for normalizing the score between lexical and KNN search, and the cross encoder for re-ranking, and what else? The semantic highlighter, yeah. So these are different processes that you put together to create a search pipeline. But the challenge is, not the challenge, but the problem is always that you have to create them in advance, define them in advance, register them in advance before you are able to use them, right? So as the name suggests, yeah, system-generated search pipeline, it attempts to eliminate the need of having to create them in advance. So to give you an example, if you are implementing e-commerce search, let's say you want to diversify your search results and you want to have MMR, maximal marginal relevancy, now you don't have to create these search pipelines in advance. You simply have to mention it in a search class, and the search pipeline is automatically created for you on the fly. Yeah. So it removes the operational overhead that you would have. But the only sad thing is it is not available for all the search processes out there yet. Yeah. So you still have to create search pipelines. And for anyone who is new, there is a steep learning curve because you need to use the APIs to create the search pipelines. Yeah. So once again, to reduce the learning curve, to cut short the learning curve, and for those who like the click, create approach, yeah, so we have this. So you have, as you see here, right, so different templates for hybrid search, multimodal search, RAG, and also agentic search, yeah. So you have different templates which you can use, and you can also use the custom search if you want to, go beyond the basics that we have, and it would look something like this. This is a full-blown screenshot, but stay with me. So it goes like this. So we create the ingest pipeline, right? You can add a bunch of processors into it. I have the ML inference processor that can convert text to embeddings. And then, of course, you can add more processors. This is as an example, yeah. And then we have the search pipeline where I have the same ML inference processor converting the text to embeddings, yeah. And this is how you define what the processor should be doing. So I then, it allows me to pick what model I want, which field should I look at to convert the text, and once I convert the text to embeddings, where should I put it to? So basically, you can configure the entire processor with the UI. Yeah. Not just that, you can also test, simulate the entire flow in here before you start deploying it. Yeah. So it's a very nice utility, a developer tool. Yeah. But let's say you are at this point. You have created the search pipeline. Everything is good. You have deployed. The next thing that you need to know is the search pipeline working at all? Yeah. So enter Search Relevancy Workbench, an awesome tool, I would say, especially for your relevancy engineers, your data scientists. Yeah. So as it shows here, right, you have 4 different things that you can do. You can compare single query. You can like side-by-side compare, eyeball the search results. You can also do at a volume using query set. You can also do search evaluation, which is basically all the good search quality metrics, the NDCGs and the precisions. Yeah. And the hybrid search optimizer, which is slightly different from the rest of it. So if you have used the hybrid search, regardless of the vector database, let's say you combine lexical search and KNN search, right? So you need to, there's a lot of parameters, hyperparameters that you need to tune. So the normalization technique, is it z-score or min-max or Euclidean? And then you have the combination technique. Is it arithmetic mean or geometric mean or harmonic mean? Yeah. And then lastly, you also have the combination distribution, which is lexical to KNN. Is it 0.1, 0.9, 0.2, 0.8? Yeah. So if you then compute the combinations that you would arrive at, there's way too many combinations. Then how would you know which combination works the best for you? This is what the hybrid search optimizer does. I will show it in the demo, which is what I'm going to do right now. So this is the new OpenSearch dashboard. This is not just the new look and feel, but it also lets you add different OpenSearch clusters to the same OpenSearch UI. So we go past the one dashboard to one backend. Now you are able to connect to different backends, OpenSearch clusters. And you can also create workspaces, a classic multi-tenancy use case, right? And when you create a workspace, it could also be of different types, observability or security analytics, search, depending upon it. The menu changes, yeah? And of course, if you want all the menus in the world, like me, I go to the analytics. I get all the menus in the world, like that, yeah? So first thing I'm going to show you is I'm going to show you the agentic search, and I'm going to compare that with the lexical search. Yeah. So for this, I go to the search relevancy workbench, single query comparison. Yeah. I have to type the query. Of course, I'm not going to do that now. I have it in here. Yeah. And what you see here is I'm going to compare agentic search with the multi-match lexical search that you probably are used to. I'm going to use a local cluster for both. I'm going to use the e-commerce index for both. But of course, on this side, I'm going to use the agentic pipeline plot. This is a search pipeline that I created. Yeah. And I'm going to search for, let's say, Nike. Yeah. I'm going to hit a search. I have a very nice comparison here. There are 3 overlaps, 7 unique results on each side. I'm going to change this to title, make it a little bit bigger. So the results are quite nice on both sides. But of course, nobody is going to search for Nike, or nobody is going to search for jeans, right? So they're going to be a bit more explicit, right? And I'm going to make a typo here, right? Nike black. Okay. Nike black shoes. Oh, one more unintentional typo. But yeah, agentic search is able to handle it, right? So if you now look at the results, right? This is no longer Nike. I mean, it is still shoes, yeah, but it is no longer Nike. On here, I have much more, as an end user, I find this one much more relevant compared to the other one, yeah. So now let's continue the journey. Let's say under $50, yeah. So now I no longer get the shoes. I get cookies. I get whatnot, yeah. Once again, on this side, I have much more relevant results. Of course, I show socks here. I'll show you why that is happening. But also, $50, you get what you pay for, right, with this inflation. Yeah. So I'll show you what happens under the hood. There's no magic. Yeah. So for this, we go to the AI search flow page. Remember, this is the one I showed you, and this is the one I use, Agentic Search, for creating this workflow. This is the one that I created. And the agent I have, this is the agent that I created. So let's run the search first before I start explaining it. And this is exactly the same search that I did, and this is exactly what is causing the magic, right? So Agentic Search is able to break down the user query, understand the user query, break it down into, let's say, Nike is a brand, shoe is a category, black is a color, and price is a range. Yeah, and this is how, and this is still lexical search. There is no KNN, there is no sparse search, there's no nothing. There's just lexical search, just a powerful rewriting of the query, right? I get the raw results, the exact same results, just to make sure that I'm not cheating. Yeah. So now we go to the raw result, raw response, right? And we see in the category for the first result, right? So clothing, shoes, jewelry, and athletic socks. No wonder this is actually showing up. Socks is showing up in the shoe because this is more of a cataloging problem, not an agentic search problem. Yeah. You also get the rewritten query here, but who is going to rewrite it? Which is what is happening on this side. So we have this query planning tool. This is the tool for this agent. And as it says here, right, it is basically converting the natural language into OpenSearch DSL query by using an LLM. This is the LLM that I'm using. Yeah. Of course, I have another agent because this is open source platform. So we also have a agent that is actually running in Olama on my tiny EC2 instance CPU, yeah, Qwen 7 billion parameter. I'm saying all these things because it's super slow, yeah. But just to prove a point, this is going to give me the exact query if it doesn't fail me. But the bottom line is you are able to, you don't need a super special Claude 4.5 model. You are able to do with a model that is just under 5 gigabytes. Yeah, so you get the same exact query, same exact result. Yeah. So and of course one last thing I want to say is you can also, if you want to be a bit more deterministic, yeah, do not want the LLM to hallucinate, you can also use such templates. Yeah, which can take a bit more control. I think I'm taking more time than maybe I'm running a bit late, but I also want to show you these things that I was talking about earlier, right? So we did a single query comparison. There is also a possibility to do a voluminous test, yeah, with the query set comparison, right? Which is what I did here, right? With the 150 queries, you get all the ranking similarity metrics here. There's obviously a bug in here which is fixed in the next release, which Dodon is going to talk about, but you basically can, what you did at the single query, right, can be seen at the volume here, right? But I like to actually show this one, the search eval, right? Because for this one, if you go back, search evaluation, right? This is also voluminous. I'm going to pass a query here. This is just a fielded query, right? But what I also I'm passing here is the judgment list, because for such quality metrics for NDCG and for precision, you need a judgment list. So OpenSearch allows you to add either implicit or explicit judgments. Explicit, you just have to find it somehow. Implicit, you can use a project called User Behavior Insight within OpenSearch. Yeah, it allows you to collect click metrics. Imagine Google Analytics, but search specific. Yeah. So take a look at the project. Yeah, it's quite interesting, at least for me as a search engineer. So the most nicest thing is for your data scientists to be able to look at it at a very take a step back, have a holistic picture. So we paint a nice little dashboard for it. Yeah. So in case, I'm not going to go over what is what here, but just to make a point that you can, so you can just install the dashboards and you get this nice stuff. Yeah. And then lastly, the hybrid search optimizer. I told you the different combinations for the hyperparameters, right? So when you actually run it, you can actually see T-towels is a search query. It ran for 0.8, 0.2 Euclidean harmonic mean, 0.5, 0.5 Euclidean geometric mean, so on and so forth. You get the idea, right? So it ran for every single query, every single combination out there, yeah, right? And then it tells me, let's go to the dashboard once again. It tells me which combination is the best combination, best hyperparameter combination for me, for my data set, with the judgment list that I am giving, which is basically the arithmetic mean, Euclidean, 0.1, point whatever, I'm not able to see it. So this is the power of this search relevancy workbench. Try it out, and I think I will have to change screen. So.
Thank you so much, Ashwat. Give him a round of applause. Come on. He did a great job. And the demo gods were with us. So we saw, we'll show you the QR code, so you can actually run the demo yourself using the DevTools API, or of course through the OpenSearch dashboards UI if it's more comfortable for you. So you can do this. And it doesn't connect to the screen, the external screen. Next up, Ashwat will show us some more search highlights in V3. Go ahead.
Yeah. Thanks, Dotan. So I think we are running out of time, but I want to tell you this one, right? So Dotan was talking about the PPL, the pipe processing language. So this is more or less a kind of a new programming, not programming, like query language. So what we have is also a natural language ability to convert the natural language into PPL query. Yeah. So as you see here in this nice little animation, right? So you don't have to, for using it, you don't have to know the query get-go, right? You can learn it along the way. But for more advanced users, there's also nice little dashboards that is automatically created when you use the natural language to PPL. Yeah. But for more advanced users, you can also create complicated queries. I will leave that there. I'm not going to say what kind of complicated queries, but there are also new commands that you can use, like regex. You can also use grok pattern. You can also use ML for k-means and random cut forest. There's a lot of new commands that are possible with PPL, but the most striking thing for me is the ability to join. So join is a new command that is released in PPL, something that is long-standing, often asked. Now you're able to join multiple indices in one place. Yeah. Subquery is also possible. I'm not going to go over the rest of the stuff here, but I'm going to pass it over to Dotan. Yeah.
Thank you. So I want to talk a bit about performance because, we're all about performance, and performance has been a point of emphasis for the OpenSearch community since its origins. A lot of users actually choose OpenSearch for its ability to ingest and manage and explore massive amounts of data, but with massive amounts of data comes obviously a premium of the performance. So we strive to build the most performant search engine out there, and which is obvious since version 1, and this is why I brought you this plot from 1.x to 3.x, so you can see. And actually, the gains have been so big that we built a logarithmic y-axis. So when you see the graph going down, it actually means that it's been decreasing exponentially. And in fact, the one that is average across all query types, which is the big 5 workload that you probably know, the benchmark, that's the dotted line in the middle, has improved 10 times from 1.3 to 3.x, so pretty nice things that to see. And by the way, it's not just about the query latency. We also see a significant performance in the ingestion, in the storage, in throughput, in the transport. There are dozens of new features in version 3 that contribute to these performance boosts. So we're running out of time, so I won't go over all of these, but just to give you some highlights. First, the GPU acceleration. We all know here in the search devroom that vector operations are heavy, especially the distance calculations and the KNN. But on the other hand, they lend themselves for parallel computation with GPUs. So as part of the project, we've introduced ability to leverage NVIDIA architecture and the CUVS Kagra algorithm. It shows pretty impressive results. As you can see, 9.3x improvement there on the indexing speed, reducing costs by nearly 4 times. That's on the GPU acceleration. Another cool thing is Lucene over FICE, because we know that Lucene, or many of us know Lucene, is memory efficient but doesn't scale very well. And on the other hand, FICE scales very nicely, but then again you need to load the entire AgenSW graph into memory. So we came up with this clever thing of Lucene over FICE that gives the best of both worlds. Tried out, pretty new, looking forward to see. The initial tests show impressive results. gRPC with protobuf, again, a very good way to for faster, more efficient data transport and data processing compared to the JSON and REST. Especially with significant heavy operations like bulk indexing, KNN search, and all of these. And also it enables use of platforms such as Apache Arrow and Arrow Flight. So Arrow, I don't know, there was a great talk yesterday for those who attended in the databases devroom, but essentially it eliminates the serialization and deserialization overhead, and also it allows for streaming architecture with processing aggregations, because it can allow to deliver partial results to boost complex aggregations. I mentioned briefly before about the reader-writer separation, so that you can separate the search and the indexing workloads to avoid the congestion and get more predictable performance, and many more. Again, I won't have time to go over all of these. So I want to say a word about what's coming next. The OpenSearch project builds on an 8-week release train, so there's always good stuff coming around the corner. And in the coming month, we're going to release 3.5. And I wanted to just give you a taste of some of the innovations in search and observability, at least the ones that I particularly like. So in OpenSearch 3.3, the before last release, we've added skip lists for date histograms, for those who don't know. So with 3.5, we're going to add skip list support for aggregations. So for analytics use cases, this offers alternative for the multi-range traversal that's much more efficient for certain frequently used query types. For example, if you have a query that queries on filters on one field and then searches on another, or things like that, we really see at least 2 times faster and so on. Another one is that the next release will introduce APM support, application performance monitoring, with support for Prometheus, for metric data, open telemetry as the instrumentation standard. So APM support, really cool thing coming next. And last but not least, at 3.5, we're going to introduce agent observability for root cause analysis. So that's pretty cool, not having our agents as black boxes. We'll be able to analyze the performance and refine our prompts based on that. So it's going to be released as experimental. We want folks to start getting their hands on and give us feedback to understand. It's all new to all of us, of course, so to get a sense of this is the right direction as a community. And beyond 3.5, there's a lot more. We're talking about decoupling from Lucene and opening up for a composable, pluggable architecture to introduce more engines and more formats, for example, Parquet as a support, and much more. So do stay tuned. And where is that? Where it is? Then, of course, the GitHub repo and GitHub org with 140 repos actually. We have a very active Slack channel instance with thousands of participants. We have our forums. There's also the tags, technical advisory groups. I'm honored to be a lead for the observability tag. We have a monthly calls open for everyone and Slack channel for that. So if you're into that, do join. We have user groups around the world, around 19 countries, I think, around the world. And also the OpenSearch Con events around the world. I just came back last month from OpenSearch Con Japan. That's the bonsai tree here. And we're going to have OpenSearch Con Europe, assuming most of you are based in Europe, in April in Prague. So you're all invited to join. By the way, it has a special track for Apache, Lucene, and Search. So even if you're not specifically with OpenSearch, but the broader search community, we welcome your participation. Also CFP for the following ones. Check it out. And check out the QR code. All the links are there in one page, including some other stuff like roadmap, like the playgrounds that you can play online, and so on. And of course, Ashwat and me are here, happy to answer any questions after the talk and also after the conference. So we put the QR code so you can contact us also online if we don't get to chat here. So feel free to contact. We'd love to hear your question, your feedback about this talk, and anything in between. I'm Dotan, this is Ashwat, and thank you very much for listening.
You have 30 seconds.